I hope all of you have marked the attendance, no? Okay. So I hope all of you have marked the attendance. So we will start the session and okay. So we have already covered two learning outcomes. Okay, learning outcome one and learning outcome two is already covered. In learning outcome three, mm, we have one main objective, that is to design a simple measuring instrument. Okay, so we will try to do this. So we have some weeks, no, around 4 or 5 weeks more. Okay, so we will try to design a simple measurement instrument. Okay, so here you can see that we have to understand the use of embedded control in instrumentation. Okay? So we will try to develop a, a measurement instrument using embedded system. Okay, embedded system means using a microcontroller or maybe Arduino development board or something. Okay, or if we couldn't practically develop it, at least we will try to simulate. Okay, okay. So I hope in learning outcome three we have to discuss some terms. Okay, so there are some terms related terms. Okay, so I think most of these already discussed. I hope. Okay. For example, we have discussed about transducer. Can anyone tell what is a transducer? So, actual transducer, we are mainly focusing on electronics transducers. Okay, we are mainly focused on electronics transducers. Okay, so there are many transducers, many type of transducers. Okay, there are. Wait for a moment. Okay, so we have already discussed about transducers. Okay, transducers. What is transducers? Transducer means any equipment or any component that is converting one maybe energy form. Okay, one energy form into another energy form. Okay? So that is normally a transducer. Okay, so this is normally a transducer. So we are mainly talking about electrical transducers, electronics transducers. Okay, so there we convert something into electrical energy, electrical signal. Actually. Okay, so there may be any uh, real world parameter, and we connect it to electrical signal, Okay, so this is a transducer. Actually, this is a transducer. Actually, this is called input transducer because the output is electrical signal. Okay, the output is electrical signal. So this electrical signal can be used as an input to an electrical circuit. Okay, so that is we called input transducer and also called sensors. Sensors. Okay, so there are other transducer, another type of transducer. We call them output transducer. Output transducers. Okay, what is output transducer? That means we convert electrical signal. So the input to the transducer is electrical signal, and output may be a real world parameter or a real world energy form, real world parameter. Okay. Okay. So these are out output transducers, sometimes called as actuators. Actuators. For example, if you consider a motor, okay, when we supply power, the motor is rotating. So we input electrical signal. The output is movement, no, dynamic energy. Okay, I don't know the energy type. Okay, kinetic energy. It is called kinetic energy. I don't know. Okay, so there is motor is a output transducer, kind of output transducer. So for example, here input transducer. So there are many input transducers. Okay, so if you consider microphone, that is converting now sound into electrical signal, that is a input transducer. Maybe some thermocouplers are there. Okay, so you know what is thermocouplers. Okay, thermocouplers can convert uh, heat to electrical signal. It is just like what is called photodiodes. Okay, thermometer also known as. Okay, uh, so okay. Uh, so you can see. Okay, so it produce temperature dependent voltage. Okay, so once when it is heating, it is creating voltage. Okay, so that is input signal, because the temperature is in other way. In other words, temperature is converted into voltage. Okay, so that is the input transducer. So microphone, thermocouplers. So there are many things, no? Okay. So here the speaker is output transducer, because we give the input. The input is electrical signal to the speaker. The output is the voice, no, sound. Okay, so that is the output transducer. Okay, so there are two type of transducers: input transducers, sometimes called as sensors, and output transducers, sometimes called as actuators. Okay, so those are the transducer type. Okay, and actually there are some parameters related with this transducer. Okay, so maybe you can refer your reference book. Okay, so here one section is for transducer, chapter 13, transducers. Okay, so you can see, you can read this thing. So you can read the introduction. Okay, so in introduction, there may be what I have explained you now. Okay, so just read it. Okay, and these are some parameters related with transducers. Okay, so I told you that we are talking about electrical transducer, because one signal is electrical signal. Okay, so one form is converted to electrical signal, or electrical signal is converted to another signal. Okay, so we call them electrical transducers. Okay, okay, so these are some parameters related with electrical transducers. Okay, maybe it is better to note down these things. Okay, so you know what is transducer, the two type of transducer. So first thing is what is transducer. Now you know what is that. It convert one energy form into another energy form. Electrical transducer means it convert another energy form to electrical energy, or electrical signal, or electrical signal into another energy form, or maybe real world parameter. Anything, okay, you can write. Okay. So that is not definition. That is just the explanation. Okay. So explanation may be enough. Okay. So you need to get the idea. What is this? Okay. Then the type of transducers. Type of transducers. You can note down this one also. Type of transducers. Input, output. This is we call sensors. This is we call actuators. Actuators. Okay. So you can give some example here. The sensor is a microphone, thermocouple, thermocouple, photodiodes. Photodiode also a transducer, input transducer. If you get light, you can get current. Okay, okay, that is photodiode. So there are many type of transducers. Okay, input transducers, sensors. Okay, and so there are another sensors also, flood sensor likewise. Okay, ground sensor like this. Okay, so input is some kind of flood. Okay, then it generate related output. Okay, maybe short circuiting or something, we don't know. Okay, so somehow it convert that one into electrical signal. Okay. Uh, and the actuators, example for actuators are speakers, bulb, bulbs, LEDs, bulbs at the bottom, motors, motors. Those are actuators. So you can write some example. If you have this idea, you no need to note down these things. Okay. These are some general terms. Okay. Actually, for example, if you consider flood sensor. Um, for example, if you consider thermocouple and flood sensor, there is a difference between these two sensors. Can anyone guess what is that? If you consider thermocouple or photodiode, let's say that photodiode and this flood sensor, okay, or smoke sensor, flood sensor, smoke sensor, okay. So there are many type of sensors, okay, and fire sensors, okay. Actually, there is one. Okay, let's don't consider fire sensors, okay, fire sensors, but there are there is a significant difference between this kind of one, thermocouple, photodiode, that kind of sensor, and this flood sensor, smoke sensor like this. Can you guess what is that? What is the main difference? No, it will not be a problem, okay? Because you no need to mark the attendance for the mid-exam, you need to submit the paper. Okay? Then based on the paper, I will evaluate the mid-exam, okay? So if you haven't marked, maybe you can mark now. It is expired, okay? So, so I will open another attendance uh, after some time, okay, then you can mark the attendance, okay. Don't worry, I will reopen the attendance, okay. So can you, so actually thermocouplers are in our labs also, okay. So a thermocoupler can be uh, directly coupled to these multimeters, okay. Multimeter, then multimeter will show the temperature, okay. So what is the main difference between this thermocoupler photodiodes like sensors and this flood smoke, that type of sensors? So maybe you should be able to understand that one, actually. No need. Okay. So I will open the attendance once again. Okay. Uh, the, the already marks student, no need to mark it again. Okay. So if any student has marks mark the attendance, no need to mark again. Okay. Don't worry. Okay. So what is the main? So there is a difference actually between this one and this one. For example, if you consider thermocouple, okay, thermocouple, it is, I don't know the composition, okay, I don't know how it made, okay, I don't know how it made, so it is related with the material, okay. So photodiode, you know that photodiode is made by combining two junction, P, two parts, P material and N material, making a PN junction. So once the light impinging on this, okay, it will create a current, okay, it will create a current. So there is a process in this term upload. So I don't know that the process, okay. What I know is when this is heating, electrical voltage or current is generated, okay. When this is heating, electrical voltage or current is generating, and that voltage or current is proportional to the temperature. Okay. So by measuring the voltage, you can measure the temperature. Okay. So so you can see that when something, for example, when we are heating this, a voltage or current is generated. Okay. So you no need to give a supply voltage to here. You no need to give a supply voltage. This one. But front sensor, if you consider front sensor, okay, flood sensor, actually flood sensor may be like this, okay. I just now I doesn't have a flood sensor. There are different type of flood sensor. Okay, it has two pin. Thermocouple also has two pin, okay. Thermocouple also has two pin, okay. So I will show it in the lab, okay. So if you consider flood sensor, okay, this is I hope a flood sensor, okay. So, most of these are flood sensors. Some sensors are wireless sensors. Okay. Some are wired sensors. Okay. Mm, this is look like a smoke sensor. I don't know. Okay. But you can go to the details and check. Okay. Uh, so there are some flood sensors familiar to me. I couldn't find them here. Okay. Anyway. Uh, anyway. So maybe this kind of one is a flood sensor, okay? So you can see that two terminals are there, plus and minus, okay? Two terminals are there, okay? So when the water touch this sensor, it doesn't generate any voltage. It doesn't generate any voltage, okay? Uh, what will happen? If the voltage is not generated, what type of things we can do to measure to check the flood? Can anyone guess? So maybe you can make a homemade flood sensor actually. Okay. So very easily you can make. So so it is like this. Okay, I can make one. Okay. So like this, I will do this kind of things. Okay. So maybe that is not working properly. Okay. So I'm just telling you example. Okay. So I will take this kind of cup. Okay. And I put some salt here. I put some salt here. Then I put two wire, okay, copper wire or copper conductor, okay, and I take them like this, okay. So this side I connected to a battery, okay, and this side I connected to a bulb, okay. So if I have this kind of setup, so maybe I can sense the flood. How? So you can see that when water is filling, maybe up to here, okay. So you can see that here some salts are there, okay. So salt has some ions, plus and minus ions, okay. So you will have some ions here. So that is conducting. This is a conducting flood, okay. So if it is a salt, what is called? Dravanati, okay. Liquid, fluids or something, okay. So it is conducting, no? Okay. So now this cable will be short circuited. Okay. So the current will flow through this. Okay. The circuit will be will be will be closed. Then the current is flowing through this. Okay. So then this bulb will be light up. Okay. So that is a sense. Okay. Actually, that kind of the same concept is there for many flood detectors, flood sensors. What you are doing is you have only 2 points, okay, 2 points. When flood touch this, somehow this cable is shorted. These 2 points are shorted, okay. That is the operation principle of many flood sensors, okay. So I just ask you to put some salt here. Maybe it is dissolving in the water, then it will make a good conducting fluid or conducting liquid, then this cable will be short circuited. Okay. So maybe this is not working properly. Okay. You can try it. Okay. Maybe this is not working properly. Okay. This is not working properly. Maybe I don't know. Okay. So there are some advanced techniques we can short when we touch the flood or maybe smoke. We can short these two cable. Okay. Then then it may be a relay. Here it is connected to a relay, okay, with 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 power or something like this. Okay. So here some power is connected to the relay. Okay. So once this is short circuited, okay, this one also short circuited. So there is a path between this one. Okay. So the current is flowing here. Okay. So now you can see that. So what is the main difference? Okay. So thermocouple creating current. Thermocouple as well as flood photodiodes will create the current. It doesn't need any voltage to operate. Okay. Actually, that is not operating voltage. Okay. But to get the output, but to convert that temperature into voltage, you no need to convert this temperature into voltage, you no need to give a additional supply. Okay. So it will generate a current. Okay. When this is heating, thermocouple will generate current. Okay. For example, if you have a photodiode, when the light impinges on it, okay, the current will be there. Current will be created. Okay. So you don't need any additional things to convert this light into any additional voltage source or battery or power supply to convert this light into a current, into a voltage. Okay. So these are called actual passive sensors. These are passive sensors. Okay. But here, if you consider flood sensor or smoke sensor, it can only be short circuited. Okay. It can only short circuited. Okay. Then you have to give another power supply to convert this flood into a voltage value. Okay. You need to have a power supply. Okay. So this kind of sensors we call active sensors. Okay. So there are two type of sensors mainly. Okay. Active sensor and passive sensor. I hope you understand it. Okay. So if you any problem, you can write it. Okay. So there are two type of uh, transducers. One is active and one is passive. Okay. So active means you need to give a supply voltage, some supply voltage. Okay. So for example, many flood sensors, smoke sensors like this. Okay. So it is short circuited actually. The terminals will be short circuited like this. Okay. Short circuited, you can write, draw it anyway. Okay. Short circuited the cable. This kind of cable is there. So this kind of one is there. So once it is shorted. Okay. Active one. Okay. So you need to have a power supply like this. Okay. You need to have a power supply like this. Okay. So these are active and passive. For example, here no supply voltage, no VCC. Okay. Uh, so thermocouple, then uh, then mm, photodiodes, photodiodes. Those are passive, uh, passive sensors. Okay, and you know that microphone is also a active sensor. Microphone is an active sensor. Okay, because we have to give a power to the microphone. We need to put a battery to work the microphone. Okay, so microphone is an active device, active sensor. Okay, so there are two type of sensors, active and passive. Okay, so you can note this. Okay, what is a transducer? Okay, and type of transducers, sensors and actuators. Okay, many almost all the actuators are active. Okay, because for actuator we need to give a power. Okay, I'm talking about sensor. Okay, Almost all the actuators are actually electrical actuators are we need to give a power supply. So actuators are normally active. It is not passive. This is nature. This is naturally active. Actuators are naturally active. But sensors may be active sensor may be there, passive sensor may be there. Okay. So please note them also. What is a transducer? What is an electrical transducer? Type of transducer. Give some example. Write it. You can somehow write it, note it. Okay. You have to note it. What I'm saying, you can note. You can take a note. Now you are engineering students now. Okay. You are not A-level student actually. So you should be able to take your note, take your own note. So this thing you should know what is a transducer, what are the type of transducers, what is active sensors and what is passive sensors. That idea you need to have. Actually, those are basic things, okay? Just common sense, okay? So active sensors, we need to give a supply, but passive sensor, we no need to give a supply. Examples are thermocouplers, photodiodes, that kind of things. So active sensors, example for active sensors are uh, LED, sorry, photodiodes, sorry, flood sensors, smoke sensors. Okay. So fire sensors, some fire sensors are active, and some fire sensors are passive. Okay. So if you need more details, you can go and search the webs. Okay. So this basic idea you should have this basic idea. Okay. Okay. Now, um, these are the basic parameters that a transducer should have. Okay. These are the basic properties, maybe. Okay. Properties or parameter that a transducer should have. Okay. Actually, this is a property. Okay. This is a property. And this is also maybe a property. No? Size is a property or parameter. I don't know. Okay. Okay. So there are different parameters. This one, linearity. What is linearity? So for example, I told you that the thermocoupler, when the thermocoupler is heating, according to the temperature, there is a generating voltage and it is proportional. Okay. It is proportional. Okay. So the this is has a linear relationship between temperature and voltage. When the temperature is increasing, voltage also increasing in the same scale. Okay. So maybe it is like this. Okay. So for a thermocoupler, uh, so maybe the maybe for 2 Celsius, it will generate maybe let's say that 4 volt. Okay. So that means for Celsius, it should generate 8 volt. Okay. So if this kind of relationship is there, okay, so that transducer is a linear, the ideally linear transducer. Okay. Okay, so this linearity property is very important. Okay, if it is not linear, sometime it will make errors. Okay, if it is not linear, sometime it will make errors. Okay, actually, when we are talking about errors, can you remember that we have talked this kind of parameters, no linearity. Okay, so this is directly related with the errors. Okay, it should be linear as much as possible. Okay, sensitivity. We have talked about this one. So sensitivity. What is sensitivity? Maybe you can remember. If we are giving if we have any instrument or component, if we are giving any input, this input can be anything. Okay. Then according to this input or the parameter change. So this input is the some change in parameter. So according to that change parameter, another parameter may be changed. That is the output. Okay. So sensitivity is the ratio between output and input. Okay. So these input and output forms may be not equal or may be equal. Okay. For example, okay. For example, so that is here mentioned. Okay. Output per unit change in the physical parameter. For example, let's say that you have a temperature sensor. You have a temperature sensor. Okay. So when this is heating, when the temperature is increasing, it is creating a voltage. You know that. Okay. So for this sensor, temperature is the input parameter, voltage is the output parameter. Okay. So output parameter divided by the input parameter. That is the increase of sensor, increase of uh, temperature. This is we called as sensitivity. Okay. Sensitivity. So, so this ratio means we are calculating this output per unit, this parameter, unit input. Okay. For a unit input. Okay. So if this is a if this is a temperature sensor, for example, let's say that for 2 Celsius, the voltage is changing 4 voltage. Okay. So input is 2, the output will 4. Okay. Then for unit input, that means for 1 Celsius, okay, the voltage increment will be 4 over 2, that is 2 volt per 1 Celsius. So this is the sensitivity. Okay. What is this dynamic range? Dynamic range means operating range. Okay. So you know that for any sensor, for example, again we take the temperature sensor. Okay, temperature sensor. So you have a range, temperature range. Okay. For example, maybe it is from 2 Celsius to 100 Celsius. Okay. If it is below 2 Celsius, maybe no any current generating from this thermocoupler. Okay. Once it's increase 100 Celsius, maybe this thermocoupler will be burnt. Okay. So always for any instrument or anything, we have an input range. No, we have an input range. That input range is normally referred as dynamic range. So that one also very important. And what is repeatability? Okay, so the explanation is here. Okay, explanation is here. Actually, this parameter is new for me actually also. Okay. Okay, these are the main parameters, and there is another parameter. mm, yeah, this one. Response. The frequency of resonant response is another very important parameter. Okay, this one. Okay. Uh, okay. So here only three. So there. So depending on different sources, maybe the uh, parameter may be changed. Okay, so the different parameter may be take into account. Okay, so we are using this. This is our recommended textbook now. Okay, so we will learn uh, as it here. Okay, don't worry. So this is also correct information. Okay, don't worry. Okay, so repeatability. Okay, so that means and so this means actually the maybe the lifetime is measuring using this one. Okay. Okay. Actually, this is also some kind of linearity, no? Okay. So that means we should be able to uh, tell, we should be able to tell the output according to the input. Okay, if we know the details, for example, if we take the same one, okay, so for 2 Celsius, okay, the voltage is 4 volt. The voltage is 4 volt. Okay, so um, so if we are taking repeated values for 2 Celsius, so it should be 4 volt. Okay, 4 volt up to some time, up to some time. Okay, so maybe if we if we are getting other values, that may be that sensor may be not used for any long. Okay, so we should stop using the sensor maybe. Okay, so that kind of information may be here. Okay, repeatability. So you can get this idea. Okay, the predictable, the transducer should be predictable over a long period of time. Okay, so that means we this relationship, this linearity should be there. If the linearity is not there, if it is not the linearity, then we can't predict, no? Okay. So that means if it is not the linear property is not there, that means that sensor may have a defect. Okay. So that kind of information is there. Okay. And physical size, that is the size of a transducer. Okay. So you can make these things, you can note these things. Okay. Linear, you know, sensitivity, you know, this is one example. Okay. Dynamic range, that is another important parameter. So when we are selecting a sensor, actually we have to mainly focusing on this one, sensitivity and dynamic range. Okay, that is the main 2 points we should pay our attention. Okay, okay. I think that's enough related with the transducer. Okay. So there are many type of transducers. You can read this if you have time. Okay. So I think that is enough for the transducers. Okay. Okay. Do you have any problem with the transducer? AC and DC which we already discussed. Okay. Now signal conditioning. Okay. What is signal conditioning means? What is signal conditioning? You know this. Conditioning means what? So you learn this. Okay. You learn many. You learn different type of signal conditioning circuits. What are they? What is signal conditioning means? What is this conditioning means? It is normal words, no? Conditioning means signal එකක් අපි condition කරනවා. ඒ කියන්නේ නිකන් මොකක්ද ඒ කියන්නේ? air conditioning කියන්නේ මොකක්ද? What is air conditioning? We are controlling the air as we wish, no? That is air conditioning. Okay? That means we are maybe changing. We are changing the temperature, no? We are changing the temperature. So if you consider what air condition do, it change the environment temperature. We don't know the process, okay? So that is the task. So changing as we want, that is conditioning. Did you get it? That is conditioning. Conditioning means, signal conditioning means we process the signal. I don't know the words is correct or not, okay? Process the signal to have a desired one. For example, amplifier. What is amplifier do? You know about amplifiers, no? Using a transistor, you can make amplifier. What is that amplifier do? What's that amplifier do? It amplify the input signal. Okay, why we need to get it amplified? To maybe to send it to another uh, circuit. Okay, that circuit need that level. Okay, so what we have done there, we change the signal, we change the input signal using the amplifier. Okay, we change it. Okay, using the amplifier. So here the amplifier is there. We change it as we wish. That is what we are doing. Okay, so that is conditioning. So amplifier do signal conditioning. What is filter? Filter is do the same thing. That is also conditioning. Okay. Okay. So that is signal conditioning. Okay. I don't know the definition. Okay. So let's see whether there are some definition. Okay. Uh, yeah, this is the word. Okay. Signal conditioning is the manipulation of an analog signal. I don't know whether this is correct or not. Why analog signal? Okay. So manipulating means any signal. I don't know. Okay. So that may be the definition. Okay. But also, actually, we are conditioning digital signal also. Digital signal also, sometimes we are conditioning using match filter like this. Okay. So we are conditioning. Okay. So meet the requirement of the next stage for further processing. You can amplify එකනොත් කරන්නේ. Okay. So that is signal condition. You can make this. You can write this maybe. Okay. Okay. And here, one example is given. For example, in digital to analog converter, there are many signal conditioning process. Okay. So one is current limiting. That means if you are sending so that means you are going to ensure the you are ensuring the range, operating range of that ADC. Okay. So maybe you need to limit the current. or voltage by applying a resistor or something. Okay. And also maybe we have to do some filtering also. Okay. We have to do some filtering also. So that kind of signal conditioning methods are using them. Okay. Okay, and this one also similar conditioning. Okay. So so actually we directly can't connect our sensor sometime to the microcontroller. Okay. Okay. So maybe it is not the output may be not equipped with the microprocessor. So you need to do some processing before giving the signal to the system. Okay, microprocessor. Okay, so you can see that this application filtering, analog to digital conversion, um, range matching, isolation. These are some signal conditioning process. Okay. So there are some single conditioning circuits, amplification circuit, filtering circuit, converting circuit. You have learned. Okay. So that is signal conditioning. Okay. That is signal conditioning. Please note them. Okay. What is signal conditioning and how we can do signal conditioning. Okay. So in measurement, the signal conditioning is very important. No? Okay. So the important is here actually. The input should be equipped with the circuits. Okay. All inputs. Okay. For measurement data or something should be equipped with the instrument. Okay. Otherwise, it will make errors or maybe the instrument damage. Okay. So the signal condition is very important for any type of circuit. Okay. It's not these things. What is signal conditioning? What are the signal conditioning process and what are the circuits we use? Okay. And you can write this example also in analog to digital converter, this type of uh, conditioning happening. Okay. Then instrumentation amplifier. Uh, Actually, that instrumentation amplifier means actually amplifier. Yeah, the normal amplifier. Okay. So normal amplifier we are using in instrument. That is in instrumentation amplifier. Okay. But I have checked it uh, in the internet. Okay. Instrumental amplifier. Instrumental. Okay. Uh, it is said that I am not sure about that actually. Instrumental amplifier. Instrumentation amplifier. Okay. Instrumentation amplifier. Instrumentation amplifier. Okay. Okay. So this one. Okay. So actually implementation amplifier means amplifier. Okay. So it said that I don't know what is this. Okay. This type of differential amplifier. You know what is differential amplifier? No? Actually, op-amps is a differential amplifier. That means it amplifies the out input difference of the input. Okay? So if you consider normal feedback amplifier, operational amplifier, okay, feedback op amps, sorry, yeah, op amps inverting amplifier, no? That is a feedback amplifier, okay? So this is a feedback amplifier. Okay? So this amplifier amplify the voltage difference, okay, voltage difference of this. Okay? So this kind of inverter amplifier is a differential amplifier, okay, the differential amplifier, okay. So instrumentation amplifier, it is said that those are made from differential amplifier, okay. So maybe amplifier also can be made using transistor, not op amps, okay. So if you are using op amps, it will be a type of differential amplifier, okay. But transistor, it is not like that, okay. It amplifies the signal. When the signal is inserted, it is amplified, okay. So, at instrumentation amplifier, type of differential amplifier, actually, if we can, so that means this here, it is said that input impedance matching. I think power student has no idea about this one. What is this matching? But I hope telecom student has idea. Input impedance matching. Okay, that means, okay, so you know that. Okay, so power student also learn this. Okay, Mm, actually that is not with our uh, subject. Okay, this is another area. What is impedance matching? What is impedance matching? Can anyone tell? Can any telecom student say what is impedance matching? What is impedance matching? So you know that if you consider amplifier, okay, if you consider amplifier, let's say that you just consider transistor amplifier like this. Okay, so this kind of amplifier. This is amplifier, no, basically this is amplifier. Okay, this kind of thing is amplifier. Okay, this is amplifier. Okay, okay. Now we need to insert a signal. Okay, so when we are inserting a signal like this, okay, so this signal will be amplified and you will have the amplified signal like this. Okay, so this is the amplifier, this is the amplifier, this is the amplifier. Okay. So when high speed, mainly in RF range, okay, RF range, high speed signal is sending, okay, okay. If, if, okay, so you are sending that signal through a cable or through a line, actually. So if you are sending sending a signal, it should be a transmission line. Okay, it should be a transmission line. Transmission line. So it is not a power transmission line. Okay, not a power transmission line. It's kind of data. Okay, it's kind of data. For power transmission line, it it is just a wire. Okay, you can use a copper cable. Okay, but for a data transmission line, okay, we need to have a special form. Okay, for example, you know that coaxial cable. Coaxial cable. This is one type of transmission line. Twisted pair. Twisted pair. That also have two copper cable. Copper pair. Coaxial cable have a copper pair for plus and minus. for ground and signal. Twisted pair also have. Okay, but these are made in different way. Okay, different way, and there are some different what is called correct impedances are there. Okay, there are some impedances also. We call them characteristic impedance. We call them characteristic impedance. Maybe uh, if you have learned electromagnetic, you learn these things. Electromagnetic, telecom student definitely not learn this. Okay, for electromagnetic subject, you should learn this characteristic impedance of a transmission line. Okay, so that the signal is coming through that transmission line. Okay, the signal is coming through that transmission line. Okay, so there is a specific impedance for this transmission line. For example, if it is coaxial cable, it may be 75 ohm or 50 ohm. Okay, okay, so maybe power student also have seen oscilloscope, no? Oscilloscope. Okay, I will show you one oscilloscope. Okay. Wait. I'm sorry, but I hope you can see me. Okay. For example, this is oscilloscope. I brought it from there. Okay. So maybe you can see that the power student can look. I think telecom student no need. Okay, because they have already know this. Okay. So maybe can't you see the? That is the probe. Okay. So can you see the probe? Okay. So you can see that here. So this is, so what is this connector type? Telecom student, can you tell what is this connector type? This is the input port, no? So here, no, two cables, okay? For example, if you take a power supply, you have plus or minus terminals, two terminals. But for a oscilloscope, it is not like, okay? You have given a port, okay? And this outer part is the ground part. This is the ground part, and inner part, you can see there is a hole, okay? So that is the inner conductor. So there are also two terminals, two cables, okay? But it is in this form, okay? What is this connector type? Tell me, what is this connector type? What is this connector type? This is the input connector to the oscilloscope. If you want to give a signal, okay, you get from the signal generator and connected to this one of this port, channel 2 or channel 1, okay? Then you can see the signal in the oscilloscope, okay? So what is this connector type? What is this connector type? Yes, that is BNC, okay? That is a BNC connector. You should know these things now, okay? This is BNC connector, okay? This is BNC connector and this is a coaxial connector, okay? This is a coaxial connector, okay? Now you can see it here, some parameters are there, maybe you can't see, okay? So this is the signal, okay? We are giving a signal to it, not the power, okay? It is not just power, we are going to give a data, signal. So that is why we have a transmission connector. So we have to connect a transmission line here. So coaxial cable is a transmission line, okay? So we have to connect it, okay? So here you can see that there are some marks, okay? So some range is there, peak to peak value, and there is a ohm value, okay? 75 ohm, okay? So 75 ohm means the input impedance of this port, that is 75, okay? So that is 75, okay? So coaxial cable, some are 75, and some oscilloscope you can see at here 1 mega ohm is marked, okay? So that is high impedance, high input impedance, okay? So coaxial cable normally has 50 or 75 ohm uh, input impedances, okay? But you can change the high impedance in signal generator, okay? Okay. So maybe you can check them, okay? Once you at the lab, okay? So what I want to tell you is that this is not just a port like the power supply, no? Okay. So it is we are using a transmission line to uh, give the input, give the signal. Okay. So for a circuit also we have to use. Sorry. Okay. uh, may okay. Okay. So what I want to tell you is that okay. So normally if we are getting a signal, we are normally use a transmission line. Okay. This one is also a transmission line. This one. Okay, this one. This one is a coaxial cable. This one also coaxial cable. Okay. Outer the outer conductor is there and the inner conductor is there. And what is this? This is also coaxial connector. What is this connector? What is this connector? This is also a coaxial connector, but it is small than the uh, BNC connector. This is we called what? This is we called what? This is SMA connector. This we called SMA connector. So there are different type of connector. Okay. So the input impedance for SMA connector is 50 ohm. BNC there are 75 ohms and 50 ohms. But SMA, the 50 ohms SMA connectors are there, as I know. Okay. Maybe there may be some other one also. I haven't come across with this. Okay. So I always come across with 50 ohm SMA connectors. Okay. So that is why I told you maybe wrong. Okay. Okay. So just have the idea. Let's see. Okay. So what you need to know is, okay, um, when we are input the signal, we have to use a transmission line. Okay. So there is a corresponding impedance for a transmission line. For example, if it is coaxial, that may be 75 ohm or 50. Okay. And there is corresponding uh, impedance. There is corresponding impedance. Okay. Maybe power student also has learned there are some parameters called two ports parameters. That is also related to power student, I think. Okay. Two ports parameters. Two port parameter, sometimes. Okay. Z parameter, impedance parameter, Y parameter, at base impedance parameter. Okay. So this impedance parameter and impedance parameters are calculated. I hope the power student also need this. I don't know exactly, okay, but telecom student definitely need this one. And another one, we have S parameter, and there are others, H parameter, like that, okay. For example, for transistor, you are using H parameter model, I think, okay, okay, I don't know, okay, maybe you have learned, okay. So for telecom student, these parameters are important. Z parameters, Y parameter, and S parameter. Okay. And there is another one, ABCD parameter, maybe you know. Maybe in electromagnetic part, you have done these parameters. These parameters are very important when we are designing the circuit for a high frequency. For example, if you are designing a circuit for receiving radio frequency. So our phone has, so this phone has a circuit, no? Okay. So it is a high frequency circuit. Okay, it should be a high frequency circuit. Okay, so that means it is working in high frequencies. Normally, you know that if this is 4G phone, it is operating in 108 megahertz or 206 megahertz range. Okay, so those are high frequencies, greater than 1 gigahertz. Actually. Okay, so definitely, you need to learn these things. Otherwise, there are some problem actually. Okay, so example. Okay, using this Z, you can calculate using this Z parameter that is called impedance parameter. You can calculate the input impedance of this circuit. Okay, input impedance of this circuit. Okay, so there is a input circuit, input impedance. Okay, let's say that it is some impedance, we don't know any impedance. Okay, so what happened now? This input impedance and this input impedance not match, not same. So when you are sending the signal through this, some part of the signal will be reflected. Okay, so that is happened in communication. I don't know, maybe in power this will not happen. Maybe power student can answer. Okay, I don't know. This is maybe happen in power also, but normally if it is a low frequency, this effect is not there. Okay, for high frequency, that means the current or voltage is uh, very speedily, maybe uh, maybe higher than 50 megahertz or something. Okay, so this will happen. Okay, but we are normally using AC signal in 50 hertz. No, so for that one, this may be not happen. I hope this is not happen for that low frequencies. Okay, I don't know. Maybe power student can answer. Okay, can tell me if I'm wrong. Okay. So definitely for high frequency, part of the signal will be reflected. Okay. So that is also important power student also maybe. Okay. So some part of the signal will be reflected. Okay. That means all the power not go inside the circuit. All the power not go inside the circuit. Okay. So that means some power will be reflected, will be reflected if input, if if input impedance, if impedance actually, if impedance are not matched, not matched. Okay. So here one impedance, here one impedance. So when the signal is transferred from this impedance to this impedance, some power will be reflected. Okay. So that reflected power so normally we sometimes referred as, so this is happen in voltages also. If it is the forward voltage VF and the reflected voltage is VR divided by VF. This is we call reflection coefficients. Reflection coefficient. This is reflection coefficients. Okay. Okay. Reflection coefficients. Then so this reflection happen due to this input impedance, this impedance unmatching. Okay. Let's say that the impedance is here Z1 and impedance is here Z2. So the reflection in this direction. Okay. Reflection in this direction, how can be expressed as Z2 minus Z1 divided by Z2 plus Z1, this way. Okay. So this reflection happen due to unmatch of this impedance. Okay. So if we have same impedances, this will be zero. Okay. So the reflection will be zero. Okay. So there is no any reflection. Okay. So 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 when we are sending the signal to one impedance to another impedance, we have to match that impedance. We have to equal that impedance. Okay. Actually, um, for for complex impedance, we have to do conjugate matching, conjugate matching, conjugate matching. Okay, that means if we have uh, one impedance x plus iy, so it is a complex one. You need to match this one to x minus iy. That is the conjugate of this impedance. Okay. So the conjugate matching we have to do. Okay. So that guarantee the maximum power transfer. Okay. Conjugate matching guarantee the maximum power transfer. Maximum power transfer to the circuit. Transfer to the circuit. Okay. To the circuit. So that means we need to match these two impedances. Okay. So if we come to the point again, okay. So you can see that here it is said that which eliminate the need for input impedance matching. Okay. So input impedance matching, so here it is explained. Maybe you can see it. Okay. You can see this. Okay. So you no need to the input impedance matching. Okay. But when we are designing the normal without using op amps, using amplifier, the is called transistor. If we are designing a transistor amplifier, we can design it to match the impedance. Okay. So there is no any additional impedance matching circuit. Okay. So there are some additional impedance matching circuits are there. Okay. Maybe telecom student has learned them, quarter wave transformer, complex transformer, stuff. matching, parallel stub matching, sorry, open, single stub matching, double stub matching. Those are input impedance matching techniques. Okay, so so it is said that if you are using differential uh, out differential amplifier, we know here differential amplifier is also here. Okay, so you can see it also. It multiply the difference. It it's called it amplify the difference of these two voltage. Okay, so that is a differential amplifier. Actually, op amp is a differential amplifier. Okay, so for a transistor also, this input impedance matching we can do. Okay, without adding any additional impedance match circuit. Okay, so what is that is what I want to know. Okay, so if power student need this, you can write. Okay, what is impedance matching? Impedance matching means uh, when we are input a signal from one impedance to other impedance, the signal, part of the signal will be reflected. That part is defined as reflection coefficients and like this using the impedance. Okay, so this will not come to the exam. Okay, this is just for your knowledge. I think telecom students should understand this. Okay, because if you consider your phone, okay, if you consider your phone, there are many matching techniques used in this phone. Okay, because there are many stage amplifier, filter, oscillators. Okay? So there are many components. Okay, so when you are sending one signal to another component, that impedance matching will be should be there. Okay, otherwise your circuits will not work properly because finally no power. Okay, so for example, if you haven't sent the total power here, this so let's say that half of power you have sent, then you have amplified that half of power. So that amplification level may be not enough to the next stage. Okay. So the input impedance matching is very important. Okay. So you can write if you need this. Okay. The impedance matching that is for when the signal is transmitting from one impedance to another impedance, the signal will be reflected due to unmatching of the impedances. Okay. Okay. So that reflection is actually VSWR. I think you know most of you. VSWR happened in this due to this problem. Telecom student know what is VSWR. Okay. The VSWR is defined using this reflection coefficients. You know it. Okay. Okay. Um, so that is that. Okay. Power will be reflected to minimize that reflection power. You need to match those two impedances. Okay. So there are many matching techniques. Okay. There are many matching techniques. Okay. So if there are complex impedances are there, maximum power transfer will guarantee by conjugate matching. Okay. So that is what you need to write. Mhm. That's enough. Okay. So if you need to know what is VSWR, VSWR, you know that it is defined as reflection plus forward, reflection minus V forward. This is the VSWR. No, this is VSWR, as I can remember. This is the VSWR definition of it. So if I divided this by VF, okay, VR divided by VF. Here VF minus VR, okay, VF minus VR. So VF minus VR, okay, VR plus VF, VF minus VR. I will write it again, VF plus VR, VF minus VR. So if I divided all these things in VR, okay, VR, VR, VF divided by VR, that is tau. So here it is tau plus 1. Here VF divided by VR, that is again tau, reflection coefficients, minus 1. This is VSW. This is the VSW. Now, this is the definition for the VSW. Okay. So what I want to tell you is that input impedance matching also can be done in transistor amplifier also. When we are designing a transistor amplifier for radio frequency, you need to design it for a specific impedance. Okay. So when you are doing project, okay, especially telecom student project, telecom students will do some projects, related with communication for their final year. Okay. So when you are designing an amplifier, filter, that kind of things, you always think about the input impedance. You have to design the circuit for relevant input impedance. Okay. Okay. So that is very important. Otherwise, your circuit will not work. Okay. So that is that. Okay. Uh, So that is instrumental amplifier. Actually, this is the simplest instrumentation amplifier schematic. Okay. Okay. So normally this is referred as instrumentation amplifier. Okay. Using op amps. Actually, there are 3 op amps. Okay. Okay. I will give. Okay. I will give you some example. Give you some introduction. Okay. Okay. So this is amplifying instrumentation amplifier. Okay. This is a schematic circuit. You can draw this one. Instrumentation amplifier. This circuit you can put. Okay. You can draw this circuit. Please draw this. Okay. So there are 3 op amps we use. 3 op amps are used. Okay. And this is the input output relationship. The gain of the circuit, AV. This is the voltage gain of the circuits. Okay. So you can draw this circuits and you can draw it here. That is the instrumentation amplifier. Okay. So using 3 operation amplifier, we can make instrumentation amplifier. Okay. So that is enough. Please write what is amplifier, what is differential instrumentation amplifier. For instrumentation and amplifier, we are using differential amplifiers. Okay. Okay. So it is here now, so you can write it here, but I'm not sure about this one. Why? I don't know why it's put like this. Okay. Because this impedance matching is not only for instrumentation amplifier, it is also for the transistor amplifier also. Okay. Okay. Just write this. Okay. Then data acquisition and transmission circuit. What is data acquisition? What is data acquisition means? Data acquisition means you know that. What is that? Okay. So you know that, for example, data acquisition means we are acquiring data. We are acquiring data. So there are some data acquisition system. Acquisition system, I don't know. Systems, okay. Maybe this letters may be wrong, okay. So data acquisition systems are there. Okay. For example, if you consider, let's say that you want to get temperature values. Okay, you want to measure the temperature. Okay, let's say that from and 6 a.m. to 6 a.m. to 5 p.m. You need to measure the temperature. Okay. So you have to use a temperature sensor. Temperature sensor. So what is that temperature sensor? So depending on the temperature, it will give us a voltage. Okay. So you can get the data here. This is a data. That means you get the data. Okay. Then you need to store this data. Okay. You need to store this. Okay. Maybe you are storing the temperature maybe after 1 hour. So you are measuring the 6 a.m. Then after 1 hour 7 a.m. After 1 hour 8 a.m. Likewise, you are storing the uh, data. Storing the data. Okay. Okay. So there are some other processes also. Okay. So these are some most important process. Okay. You get data and store. Okay. So actually that is data acquisition. No? That is data acquisition. Okay. So using a temperature sensor, if you mark the temperature of the day between some time, that is a data acquisition system. Okay. That is a data acquisition system. Okay. So maybe that transmission means, so when you are uh, storing this, sometime maybe you have to process them. I don't know the processing also in the acquisition system maybe. Okay. So maybe you need to send them. You need to send them. Okay. So that is sending maybe the transmission, referred to the transmission. Okay. So that is data transmission and acquisition system. Okay. So data acquisition, if you see, okay. So this is the data acquisition. That is a process of sampling signal, measured the world physical condition and converting the result sample into digital mnemonic, and that can be manipulated by the computer. Yeah, that can be manipulated by a digital system. Okay, that is data acquisition. Okay, that is data acquisition. Okay, so you can mark this. Okay, so simply, so you know that. Okay, so you know that. Here we got from here we got actually analog values. Here we have analog signal. So that analog signal maybe we have to convert into digital signal before store it in the RAM. Okay. So that is why we need sampling and analog to digital conversion, because real world data is always analog. Okay. So we need to have analog. Okay. Process of sampling. We have to sample them. We have to get some sample. Okay. You can get that idea in any way. Okay. For example, you need to get sample, temperature sample. After, so you get one sample at 6 a.m., another sample at 7 a.m., likewise. Okay. And then you need to convert that sample into numeric value, digital numeric value. So that is actually the analog digital conversion. Okay. Then that can be one. Here, the data also should be stored. Okay. Otherwise, it is hard to manipulate. Okay. So these are the main components of data acquisition system. Maybe you can write them also. Sensors, that is we use to read the physical parameter. Then signal conditioning. That means we need to convert that signal into the appropriate level, appropriate value. So maybe analog to digital or something. So that is signal conversion, conditioning. Okay. For that one, analog to digital converter may be used. Okay. So this is simple block diagram. No? That is for digital data acquisition system. Okay. physical parameter, then transducers parameter. Okay. Then you are conditioning the signal, you are smoothing the signal. Okay. So maybe before you send to digital to analog converter, uh, actually here if you are using signal conditioning, I think it is not correct because because here actually we are doing signal conditioning. In here also we are doing some signal conditioning. Maybe here also we are doing signal conditioning because this signal conditioning means signal processing actually. We convert signal into our some level. Okay. So I think here the proper name is signal shaping. Signal shaping, no? Signal is smooth. Actually, analog digital converter is also doing the signal conditioning, no? Okay. So be, because transducer have some data, so it has some electrical signal. Okay. Before give it to the analog digital converter, you have to condition. Can you just image uh, one condition, one signal condition? Actually, analog digital converter can't measure minus value, can't convert minus voltage value. This ADC, you can mark it, okay? ADC can't convert minus voltages, can't convert us minus voltages. ADC, analog digital converter can't convert minus value. Minus value analog digital loading convert කරන්න බෑ. Okay? Okay. For example, let's say that we have a signal, we have a signal from a sensor, this kind of signal. So we have plus voltages and minus voltages. So if you convert this to ADC, if you send this to ADC, the output will be, so this part will be ignored. It sample and convert the value only this value. This value will get only related to this value. This part is not, will not get. Okay. Okay. So before you send this signal to ADC, you need to do something. That is again signal condition. Please try to understand it, okay? That is again signal condition. These are very important things, okay? These are not related with actually not only with measurement, okay? But electronics, electrical power, these things are very important, okay? So before send it to ADC, before send it to ADC, because ADC cannot measure, cannot convert, minus voltages. Okay. So if you are giving this kind of signal, the total signal will not be converted into digital. Okay. So some part will be missing. Okay. So what you have to do before giving to this, what you have to do before giving to this signal to ADC, what you have to do? You know what you have to do. මොකද්ද කරන්න ඕන? What you have to do? I need the answer. All of you should know what is this. What is this? What we have to do? If we can't measure minus voltage, what we can do? This minus voltage we can't measure. Then what we have to do? You know what is that? You know the name. If you can't measure minus voltages, what you have to do? You have to, you have to shift this plus voltage, minus voltage to plus side. Like this maybe. For that, what you have to do? For that, what you have to do? So you are shifting this level. So what is we call? You have to give what? If you want to shift it, what you have to do? That is the basic things related with signals. මොකක්ද කරන්න ඕනේ? මේක උඩට දාන්න ඕනේ. මේක උඩට දාන්න නම් මොකද්ද සිම්ප්ලි කරන්න ඕනේ? දැන් ඔකට එකේ සිග්නල් ජෙනරේටර් එකේ මෙහෙම සිග්නල් එකක් එනවා. දැන් ඔයාලට මේක කන්වර්ට් කරගන්න ඕනේ මේ වගේ සිග්නල් එකකට. ඒ කියන්නේ මේකේ ප්ලස් එක කොහොම උඩට දාගන්න ඕනේ. මොකද්ද කරන්න ඕනේ? දැන් මෙහෙම සිග්නල් ජෙනරේටර් එකෙන් ওই සිග්නල් එක එළියට එනවා මෙහෙම. වයර් දෙකෙන්. ඔයාලට මේක උඩට දාගන්න ඕනේ. මොකද්ද කරන්න ඕනේ? මම මෙතන බැටරියක් හයි කරා නම් හරි මේ ප්ලස් එකට. මේක ග්‍රවුන්ඩ් එක. එතකොට මොකද වෙන්නේ? මේක සීරියස් කනෙක්ටඩ් එකක්. එතකොට වෝල්ටේජ් එක වැඩි වෙනවා. වෝල්ටේජ් එක උඩට යනවා. So if you, it is just like you are connecting the battery in series. So the voltage will be shifted up. We call this DC offset. We call this DC offset. Actually, for signal generator, you no need to add battery or something. There is a things that is called DC offset. Okay. Okay. But here, for this signal, maybe you have to add another DC voltage. You have to add another DC component. That is DC offset. Then this signal is shifted. So these are basic things. You should know that. So then you can put it to a DC. Then you can do the same, the processing. Then using the DAC, you can get the output. Output also will be like this. Okay. This offset is there. Then you have to give minus DC offset. Minus DC offset. So we have to connect the battery. So you have to minus DC component. Okay. Okay. So this one is signal conditioning, DC offset. ADC also signal conditioning. This DAC also signal conditioning. This DC minus DC also signal conditioning. All these are signal conditioning processes. So here actually this should be DC offset or something. DC offset maybe, adding DC offset, or maybe smoothing. So that kind of things, signal conditioning. So here this word is not appropriate, I hope. Okay. Then analog to converter, then computer. So you can see the storage. Okay. So this is basic data acquisition system. You get the signal, then you convert it to digital, then you store it. Okay. So that is the basic data acquisition system. Please store this also. And actually, if you consider, so you can see there are some wireless temperature sensor. Just type in internet, you can see. Okay. Actually, so it is come with the chip, and you need to give power. So those are IoT sensors, normally referred as IoT sensors. Okay. And all these things done in that chip. Okay. Within the sensor, all these things done. The data acquisition part is done. Then using that wireless sensor, using the wireless transmission media, that data is transferred to another server or something. Okay. So that is the basis of IoT system. Okay. We collect the data from a sensor, then that data is processed there and transmit it to a server or something. Okay. For the processing. Okay. But that sensor itself, that sensor part itself has a data acquisition system and transmission process also. Okay. So maybe all together it is called data acquisition and transmission circuit. Okay. So I think that is it. Data acquisition, you know what is. Transmission means that kind of things. Okay. So if you consider, if you look at wireless sensor in internet, you can get the idea. Okay. So it process the data and is store and transmit the data. Maybe not storing, sometimes it is transmitting to the server. Okay. So data acquisition and transmission system is there. Okay. 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 So now we need to learn about probes and other attachments. So probes, you know what is probes. Okay. So voltmeter, ammeter, these are measuring some voltages and currents. Okay. So you can just use wires. Okay. But you know that oscilloscope and signal generator, we have to use transmission line. Okay. We have to use transmission line. Normal coaxial cable we are using. We have discussed it before. Okay. So for the corresponding, so when you are uh, when you are selecting the probe to any instrument, that probe should be connected, should be able to connect it to the instrument. Okay, the connector type should be matched. Okay, then if it is, especially if we are measuring signal, oscilloscope or spectrum analyzer, you need to have you need to have a transmission line. Okay, then the proper impedance match transmission line you have to select. Okay, so that is why oscilloscope has different transmission line, different probes. Okay, so there are some probes for digital oscilloscope, some probes for analog oscilloscope. Okay, the main thing is the impedance. Okay, impedance will be changed. Okay, and also, so sometime when we are measuring signals, okay, so sometime uh, the signal power we don't know. Okay, we don't know the signal power. Okay, so if the power is too high, the instrument can be damaged. Okay? For that one also, we are using attenuators with the probes. Okay, with the probes, sometime uh, we are using attenuators. Then we can attenuate the signal. You can see that in oscilloscope probes also uh, there are some attenuate. Okay, okay, you can switch it. Okay, that is 100 times 10 or something. Okay, so if you put 100 tens, okay, so that is the normal signal. Then if you get to other side, it is attenuated by 100 times, 10 times maybe. Okay. So when you are selecting props, you can use especially for signal test instrument, you need to see this. Okay. 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 So I think that is enough for LO1. Okay. So next week we will decide, we will discuss about this embedded control instrumentation. Okay. Embedded control instrumentation. Okay. So we will see what we can do. Okay. So we will discuss it, what we can do. So I hope these things you get. Okay. Basically, we talks about type of transducers. Okay. Then what is signal conditioning? Okay. Signal conditioning can be anything. For example, I told you that before signal is fed to the ADC, analog digital converter, you have to DC shift the signal. You have to give a plus DC offset to the signal. Okay. By adding plus DC shift, plus DC component. Okay. So that is signal conditioning. Okay. So ADC also, there are many signal conditioning processes are there, converting, filtering, that kind of things are there. Okay. So that is signal conditioning. So in input instrumentation amplifier you see, we are use differential amplifiers. Good. It is a type of differential amplifier. Okay. And there is a matching things related. Actually, matching we need to guarantee the maximum power transfer. Okay. Otherwise, if the matching is not matched, when the signal is going to from one impedance to other impedance, one portion will be reflected. So we need to so that instrumentational amplifiers should be matched to the corresponding values. Okay. Okay. So that is we have learned. Okay, now we have talked about data acquisition system and what are the transmission circuits. Okay, oops. Okay, that is enough. I hope for in 3. Okay. Now we will mainly focus on this one. Okay. So these things I will give you as a assessment. This also will be assessment. Okay. And also you will have some lab session. Okay. From maybe it will begin on January. Okay. And related with this one, I will also give you one assignment. Okay. One assignment. Okay. I have already give you assignment using LO1. Another assignment I will provide you using LO2 and this assignment. So there are 3 assignments and lab and mid exam. Okay. So today we plan to hold the mid exam. Okay. Before that, do you have any problem with this stuff? Do you have that idea? What is transducer? What is signal conditioning? What is instrument amplifier? What are data acquisition system and how we can transmit the data? So did you get that idea? So I think this one, signal conditioning, is very important. Okay. Yeah. And we have learned, you have draw the schematic of the instrumentation amplifier. Okay. So you need to know these things also. Okay. Okay. So if you have any problem, you can ask me. Okay. And also I will tell you about the mid exam. Okay. So I have uploaded the mid exam paper, okay, to the LMS. So you can get access to it at 7 p.m. Okay. So 7 p.m. to 12 p.m. you have time to do it. Okay. That means 5 hours is given. So you need to upload your answer script as a one PDF file. Okay. So this is one. Okay. So you can get it from today at 7 p.m. Okay. So you can uh, get the paper. Okay. 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 We will stop for a moment. Okay. I will tell you about the mid exam. Okay. I have uploaded the mid exam. Okay. I have uploaded the mid exam. This one. Okay. So you can uh, you can access to it at 7 p.m. Okay. So please write it. So there are 2 questions. One is regarding with the bridge. Okay. So that is very simple. Okay. So that question is somewhat long, but the answers are very short answers expected. Okay. So you can easily do that part. Okay. And the second part is from magnetic induction, and all the equations is given, necessary equation is given, but you need to think for something. Okay. You need to use, so just you need to design one ammeter using that concept. Okay. So I have given it in different way. Okay. So normal ammeter is for normal, so normal analog ammeter, we we construct using electromagnetic effect, no? Using the Arsenal setup, okay? So it create a torque. Here I give you a force, okay? So you need to adopt it as required, okay? So that is second question. Well, that is also with the first question, okay? And at the second section, you asked about oscilloscope and spectrum analyzer measurement, okay? So you need to draw one um, signal and spectrum analyzer signal, okay? Then I give you to design spectrum analyzer or digital storage analyzer, just to draw the block diagrams, okay? So that is that very easy, okay? So maybe 1 hour is enough for the paper, okay? So there are a lot of questions, don't worry, but those questions will not take much time, okay? Okay, so that is that. So shall we now stop? Do you have any problem to discuss? If you don't have any problem, you can leave. Otherwise, you can ask if you have any problem. If you don't have any problem, you can leave, no problem.